Question 14. The points A, B and C lie on the circumference of a circle. The straight lines E, B, D and E, C, F are tangents to the circle. Angle BEC is equal to 58 degrees and angle BCA is 35 degrees. Find the size of angle ABC, so this angle here, which I'll call X. You must show all your working, but there's nothing here telling us we need to explain our decision, so I'll just do all of my working on the diagram. So the straight lines EBD and ECF are tangents to the circle and they're from the same point E. So we know that these two tangents are the same length. That's just a rule we have in maths. You'll find it in any good revision textbook or maths textbook. So look it up if you don't know that. That two tangents to the circle from the same point are the same length. So we can see here triangle EBC is an isosceles triangle. So that means these two lengths here must be, sorry, not lengths, these two angles here must be the same. We know that 180 degrees is the sum of all internal angles in a triangle. So if we take away the 58 degrees that we know about, we can find what these two angles must add up to and then divide it by 2 to find just what one of them is. So 180 degrees minus 58, I'm just going to do this quickly, so I'm borrowing the 1, 10 minus 8 is 2, 7 minus 5 is 2, and 1 minus nothing is just 1, so 122. And that needs to be divided equally between these two angles, so 122 divided by 2, 2 goes into 1, 0 times, 2 goes into into 12 6 times, and 2 goes into 2 once. So each angle must be 61 degrees. 61 degrees. We also know that this angle here, 35 degrees, must be this angle here, and this is due to the alternate segment theorem. I think I've explained this in one of my other videos, so check that out. If it's not in the WJEC, it will be in the edXL playlist. So that's by the alternate segment theorem. So if we have, and I'll briefly go over that now. So if we have a tangent to the circle and we have a number of chords inside the circle, this angle here will be the same as this angle here, and we also have this replicated in this question because we have another tangent down here, we have some chords here. So this angle X must also be the same as this angle here. And that's just by the alternate segment theorem. Alternate segment theorem. Cool. So we have a straight line and we know that all the angles on a straight line add up to 180 degrees. So I could do 180 degrees minus this 61 degrees here, minus this 35 degrees from the alternate segment theorem. I'll just write that again, by the alternate segment theorem, just so it's clear to the examiner that I know about the alternate segment theorem and this 35 matches up to that 35. So 180 minus 61 minus 35. I'm going to have to borrow the 1 again, so 10 minus 5 minus 6, so that's 4. 7 minus 6 minus 3, I'm going to need to borrow this 1. So 17 minus 6 is 11, minus 3 is 8. So 84 is our angle X. And X was just angle ABC equals 84 degrees. So the two things I've used here are the tangents to the circle from the same point at the same length, and I've also used the alternate segment theorem. So I hope that's clear enough. That's the answer to question 14. If it's helped, please leave a like, comment and subscribe. That will really help the channel and help me out. If it hasn't helped or there's nothing you don't understand, you might be a bit confused with this alternate segment theorem, please just leave a comment and I'll answer your comments, or I might do another video specifically on this alternate segment theorem. But other than that, thank you very much for watching.